Hey, welcome back. It's True again with another Cafe Yocto episode featuring the phyCORE-AM62x system module and development kit. In today's video, we're going to be discussing package management with the Yocto project. Now, first off, what the heck is package management? Well, package management for Linux is the use of a package manager software to automate the installation, upgrade, configuration, and removal of additional software packages into the Linux distribution. An example of that, if you've ever worked in Ubuntu and maybe started a Python project, you're getting started and you realize, whoa, I don't even have Python 3 installed. Well, you probably ran a command such as sudo apt-get install Python or Python 3. In that context there, apt-get would be the package manager. And when you run that command, that package manager, whichever one is included in your Linux distribution, it would check a public package feed online. It would locate the pre-built Python or Python 3 package and then install it. And essentially, you'd have access to Python 3 very, very quickly. If you've worked through the videos leading up to this episode in this series, and we've customized the board support package with the Yocto project in one or two of those episodes, building these packages and then baking them into our production-ready software is a time-consuming and resource-intensive process. So if you have ever utilized a package manager and quickly used it to upgrade your Linux distribution, you quickly realize that it's a lot faster and easier than spinning the Yocto project and building everything all at once. So for this exact reason, for customers working with the phyCORE-AM62 development kit looking for package management functionality, we at phyTech here are currently hosting a public package feed to kind of give you this Debian-like experience, specifically with OPKG, which is very similar to apt-get. It's just called OPKG instead. So let's work through this package manager guide here today together, and then we'll set up and kind of talk about how we can use phyTech's package feed, and then we'll also talk a little bit about how you might set up your own and facilitate rapid development amongst your own development teams as you go on and customize your Linux distribution further. So let's get into this. In order for us to provision the package feed into our Alpha 1 BSP, which by the way, it doesn't have it enabled by default, we're going to have to first navigate into this file here in etc opkg. OPKG is actually the package manager used here in the Arago distribution on the phyCORE-AM62 with Alpha 1 BSP, and then here etc opkg base feeds. So this basefeeds.conf file actually holds the location of the package feed, and the way it's kind of broken down, so we have this like base URL here, and then the path kind of leads you down here ultimately to these directories: all, any, no arch, and they're also listed out here over to the left. I believe this is telling you how the package is being served. But anyway, the packages are organized in these categories where the package is either applicable to all systems, some are going to be applicable to no architecture in particular, some will be applicable to only the 64-bit architecture, and then some packages are going to be very hardware specific, and so you'd have that associated with the machine config used in Yocto. So this file is actually kind of synthesized by the Yocto project, and there's a reference meta layer that we could share to enable this stuff or customize this stuff. We haven't done that in our Alpha 1 BSP because we're still trying to decide whether or not we want to do that and have people potentially rely on it in production settings. We do not want anyone to rely on our package feed for production setting. You would want to bake in all your support by default into the software image for production context. But anyway, in order for us to leverage the phyTech package feed and kind of get into rapid development with the development kit, we first want to clear out all this stuff. This stuff is just for reference, and I don't think it'll actually work. We're going to want to reference the package management guide here, and down here we actually have the exact lines that we'd want to paste in. So we grab that, go ahead and paste it in like so, and now our base package feed is properly provisioned. Now we just need to have OPKG, which is our package manager here in the Arago distribution, to go and look at the package index, which is essentially a manifest outlining all the packages available, and then it'll have an idea of what is available for us to go ahead and go install. The way we do that, we just do OPKG update. Oh, by the way, in order for this to even work, you would have to have a valid internet connection, and it's kind of hidden, but I do have valid network here on the development kit. And so now with OPKG update, now I have an idea of all the packages available. So I could actually spit all those out with list. My recommendation would be to grep OPKG list for a specific package name. So in this case, I want tree. I happen to know that tree is not available here by default. So if I want it, I can first check, is it available? And we could do that with this. So this will take a second to return, and it doesn't take too long. And we can see that tree is included here in the package feed, along with some other debug, develop, and source packages associated with it. Now, I really just want this one, and so the way I can grab that, OPKG install tree, easy peasy. And this will just take a second to get installed, but remember, the package feed is offering up a pre-built package. We're not having to build it ourselves here, so overall it will be much faster than spinning up the Yocto project just to add this one thing. So if I now type tree, I can, and this output is not very exciting because there's nothing in this directory, but if I navigate to the root and do tree, it'll basically print out the entire root file system in this tree structure. We can kind of see all these nested directories. There's a lot of stuff in the root file system, so I'm not actually going to spend time looking at that, but that's what tree is. Tree is a utility for kind of spitting out everything in a certain directory recursively. So no, that was a way of adding something that was not included in the distribution by default using phytext public package feed. So far, we've added the phytext package feed to our Linux distribution, and then we've used it to leverage pre-built packages from there, installed them into our Linux distro, effectively customizing the Linux distro without having to rebuild everything with Yocto. Now let's talk about how you can use your own BSP and your own Yocto installation to be your own package feed maintainer. This might be very helpful if you're working on a development team, you're the Yocto maintainer. Typically there's one person designated to do that. And then you could provide packages to your development team, each of them maybe having their own development kit. You can distribute packages to them via the feed so that they can quickly customize their software, thus making it unnecessary for you to compile, complete SD card images customized for each person's tasks, and then you're transferring these multi-gigabyte files to everyone. That's a mess. It's a lot more maintainable to host these packages independently, keep track of what everyone's installing, and then make like this dependency list. And then at the end of the day, when development's done, you can provision all of these packages into your production software image using custom meta layer. We've discussed that in a previous video. So that is all present there in the by default on your system in the field. So you don't have to rely on this package feed in a production setting. So anyway, let's take a look at our BSP. So we have it built here. And just to recap, we have everything built and it's all deployed here. Now the packages themselves are deployed here in IPK, the deploy/IPK. Now this directory is really great. We can actually just take this itself and turn it into the package feed. In order for us to do that, we'll have to create that package index, and that's really easy. BitBake has a target for that. First off, let's build a package that is not available for us by default. We used tree in the last example. Let's take a look at the manifest and identify something else that's not available. So I would like to try the uncomplicated firewall, UFW. This is a pretty common networking user space utility in Linux and is not available by default. So let's walk through the process of building that and making it available in our deploy directory, and then let's turn that into a package feed together. Effectively, you're able to become your own package feed maintainer this way. So first things first, let's first check our recipes and double check that UFW is even available for us to build. If it wasn't, we'd have to go look for a open source meta layer, try it out, see if UFW works with that. But good news is our default build tree has a UFW recipe. We could actually find the location of that just by looking in the sources directory, and looks like Meta Open Embedded is offering that up in this like sub meta layer, meta networking. It's this recipe anyway. But what we can do, we can build UFW by itself, and then I'm just going to queue it up in the same command, bitbake package index, and this will actually have Yocto deploy a package index. Essentially, this acts as a manifest for OPKG to parse, and then it knows what packages are available. So we just go ahead and build both of those together at the same time, and it'll take a little bit for this to return.
A few moments later.
All right, that returned. Let's take a look at what that deployed. So the first thing I'd expect is that UFW IPK in the deploy directory. So we can just quickly confirm with this command. And there we go, the IPK for UFW. And then the package index build target, that guy is going to deploy these IPK packages files. Now this first one in the root of deploy IPK, this guy's empty, interestingly. But if we go further into these, more specific subdirectories, for example, the machine, and then the packages there, this is a good example of what these look like. It's essentially a manifest outlining all the available IPKs in each of these directories. So OPKG would parse these and have a knowledge of what's available, and then uses this information also to resolve dependency information for any particular IPK that you're installing. So now with this, let's just navigate in there. Okay, so with this directory all set up, we can actually take this directory as is, host it in an HTTP server, and use it as our package feed. Now, the next step here that I'm going to walk through is kind of unique to my particular setup. It may or may not be applicable to you working alongside me, watching at home or from your your office. So it's really specific to your network architecture. So let me outline. So in the previous videos, I've talked about the fact that in this tab, my build server, I'm actually using a cloud-based build server at this IP address, specifically this 172.22.6 subnet. Now my local virtual machine, which I use for flashing SD cards, this guy, if I check, is on a 172.2.30 subnet. So my local VM and then the cloud-based build server I use are on different subnets. I SSH'd into my cloud server. However, let's hop over to my development kit. If we take a look here, the development kit is on 172.22.30 subnet. So this subnet matches my local virtual machine here, but that is different than my cloud-based build server. So if I use my cloud-based build server here to host the package feed, depending on your IT department and the network routing rules that have been set up in your office, you may have difficulty talking between subnets. I know that's the case here in phyTech America's office. So if this is applicable to you, if you're dancing around between different subnets, I would get everything on the same subnet, and that should ease a lot of the headaches that you could encounter, and that should also make it unnecessary for the IT department to get involved and open up those routing rules to enable this type of stuff between subnets. So just do everything in one subnet. So in order for me to do that, I'm going to have to copy the entirety of the deploy IPK directory here over to my local virtual machine, so that's on the same subnet, and then I can create an HTTP server and create a package feed. So the easiest way to do that, I'm just going to make a directory, make it temp, probably want to name it something like package feed, maybe the kernel version and BSP version too, if applicable. And then from here, we can just use this handy dandy rsync command I had prepared. This will recursively copy everything in that deploy directory. Remember, here's the IP address of my build server, the location of it, everything in there, and I want it all copied to this local working directory. So let's go ahead and do that together. Let's just take a little bit of time.
More moments later.
There we go. So now, If I take a look at the directory, we can see that that entire deploy IPK directory got copied in, and so we're ready to go. Now we can use a number of different methods of hosting an HTTP server. I just like using like the Python module, so I have this command handy. It's very simple. We're just going to use this HTTP dot server. I think this is the simple server that's included with Python 3. I might be wrong. Let me know in the comments if that's wrong. I think this is included with Python 3. And then the way that module works is you give it the port to open up the server on, and then the IP address to bind it to. I'm just going to use the same address as my local host here. And then this ampersand at the end, this is just to run this as a process in the background because I still want to be able to access this terminal. So we go ahead and do that. We have that HTTP server being hosted here in this directory. That's what we need to be in the temp directory. And now, if we go hop over to our development kit, let's navigate to etc opkg base feeds. We're essentially going to change the stuff that we provisioned here to point to our new server that we just set up. And the way we do that is, I actually have it all prepped. Give me a second here. Boom. And my S always gets dropped here at the beginning. So keep in mind if that happens to you. This file will have to be very, very specifically written. So if there's any typos, you could have problems. Essentially, this is pointing to that same IP address we just hosted our server on. Here's that port that we're offering this up through, and then here in particular, I'm just looking at all the Arch specific and then the machine specific. So the other stuff, that was all really provided for reference and may or may not be applicable. You could add those if you'd like. But my UFW, for example, is going to be, I believe, in the machine. Let's try. Oh, I keep doing that. Here we go. Okay, so now we have the new package feed provisioned. Now we can do opkg update. And when that happens, too, take a look at what happens over here. We get this stuff that gets spit out. So that we can see that packages was red in each of these. And now opkg locally here on the target has an idea of what's available. So now if we do opkg list and then we do a grep for UFW, we should see, yep, sure enough, there it is. And if we'd like to grab it, we can do opkg install UFW. And while that's happening too, we can see some extra output. See, UFW is getting spit out here. So we could like back up this log and keep track of all the IPKs that are being grabbed by your development team. That's one strategy. Or you could just have them tell you what they installed if they keep track. But anyway, looks like it got downloaded, and now we have access to UFW. I'm not going to actually use it, but it's there. So that's how we can use the Yocto project to be our own package feed maintainers, and then provision that package feed into the target, and then grab packages, IPKs specifically, with opkg.
And that's a wrap on Cafe Yocto featuring the phyCORE-AM62x. Don't forget to subscribe and like this video, and stay tuned because we'll be doing a lot more of these in the future.